Hello, and welcome back to another ClueCon Weekly. It's great to be back in the ClueCon Weekly studio, and this week to be joined by Bhagvan Kommadi. Hey Bhagvan, how are you doing today?
Hi David, how are you?
I'm very well, thank you. It's great to have you along this week. Bhagvan, tell me, can you just give us a little bit of information about the company you work for and what you currently do, please?
Yeah, I'm currently working as a Director of Product Engineering at Value Momentum. In Value Momentum, we have a social network platform where we have a community of doctors. It's called White Coats, and we provide telehealth support through AI platform to doctors and patients. And we recently had a COVID-19 campaign focusing on doctors, providing the latest and authenticated and verified information.
Right.
So I have
So would it be fair to summarize and to say that you're in a technology role, but it's specifically aimed at the healthcare industry?
Yeah, so my background was in also in healthcare. I had a AI startup called Architect Corner. I have around 20 years of experience working in different product companies and services companies, and I had a couple of startups, Architect Corner and Quantica Computacao, looking into quantum AI. Right? I wrote a couple of books, right, related to AI, quantum AI, and
Right.
I had a hands-on data structures and algorithms Go. And I worked extensively in healthcare, pharma, and worked with various customers, right, like Pfizer and Sun Life, Aetna, GE Healthcare, Thomson, Abbott Healthcare, right, and Kaiser Permanente, Walgreens,
Right. Names that we
GS.
would yes, names that we would recognise indeed. And so, how did you come to be in your current role?
So in my current role, what we are trying to do, build a AI platform where you can provide the voice assistance, knowledge assistance to patients and doctors, right? Through different what we call services, what we call extensions. And in the current role, we are looking at providing a platform which has capabilities to provide voice, video, audio, right, and podcast, and for the community to interact within the doctors. And you can visualize almost like a like what we are doing here in podcast, something like a room, right, where doctors can discuss about triaging a case, and they bring in in the ecosystem different players like pathology labs, diagnostic centers, and pharmacy and different hospital network to decide what's the right thing to do. And also the cost is another factor for the patient to determine, given the cost, what's the right thing to do, where will the surgery or where will the what do you call the care, medical care will be taken. And that's the overall platform. And we want to provide a telehealth support where we can use voice and video to diagnose, right, and to provide support even during lockdown scenarios like COVID-19.
Great stuff. Yes, I mean, of course, people traditionally joke that the doctor's waiting room is where you catch all sorts of infections when you're kind of sat there with other people. But in this case, you can have a virtual waiting room where you don't, where that is not a
Right.
possibility. Bhagwan, I believe you brought a presentation along with you to the ClueCon weekly studio. And so, can I hand over to you now to talk? I've come across you before, of course, because you were at Astricon a year or two ago talking about conversational AI within the healthcare sector. So I'm going to pop you over now onto your screen share, and I wonder if you would kindly take us through your presentation.
Sure.
Okay, your slide. There you go. That's right. You're showing your slide now.
Okay. So today I'm going to talk about conversational AI healthcare. Thanks, David, for great introduction. So we look at first voice, right? And I'm sure you'd have looked at different what you call voice systems, right? And I'm sure you'll be interacting with Alexa and different devices in your life, right? And like you start with at home, you have a smart speaker like Alexa, a smart device, and let's say enter into a car, you probably have a car-based assistant, which is again voice-based. You might have a smart watch, and that watch might have voice-enabled capabilities. And go to office or work at coffee shop or work at your home during lockdown, and you have a laptop that is also voice enabled. And nowadays we have smart TV, which is again voice enabled. And let's say you want to go do exercise in a gym, and you have a fitness device, which again is voice enabled, and you have headphones and smart earbuds, which are voice enabled. So voice based systems are becoming very popular, right? And why voice assistants, right? Why do we require voice assistants, and what's so special about voice assistants? Most of the time, a challenge in creating voice assistants is requests are not clear, right? Many times, human language is not understandable, right? It may not be helpful in understanding the AI responses, right? And it is typically standard, frequently answered questions, and it's like boring question based, right? And you have inaccurate commands, and speech is convenient. Most of the time, speech is very convenient and faster, right? And to avoid inaccurate responses. So, how does the speech processing work? Let's take a step back from the healthcare for a second and look at speech processing in general, right? You have speech coding, you have synthesis, you have recognition,
Great stuff.
right? And you have a speaker model, and based on speaker identity and speaker speech transcription. And you have a speech type, which looks at speech patterns and diarisation. Now, let's say you have a speaker recognition model based on a template, right? A template-based word recognition, right? These are the words, and this is how you're going to pronounce. Or you have another model which is based on continuous speech recognition, and the last one is neural network-based recognition, which where you have the learning capabilities.
Bhagvan,
Right?
can I just
And
stop you for a moment, please? Because we've
yeah,
moved off presenter mode onto the kind of your view, if you like, where it shows you the slide. That's right. There you go. We're back on. Sorry. Yeah, do continue.
right. So you have the three different types of models, right? And so typically you extract the features, you detect the speech, and that's in the neural network where you have the optional vocabulary builder, the vocabulary grammar, and you have the acoustic model and the speech and noise database. Right? So in the neural network based recognition, you have learning capabilities where you continuously learn about speech of specific to a speaker. So you have analysis, feature extraction, and a modeling and testing. So, what are the different types of speeches? Right? We have isolated words, we have connected words, we have spontaneous speech. Right? Now, John is going to fall. It's a very simple sentence, right? Whereas you have a complex sentence. Although John was wealthy, right? He was sitting with a group of people. So you see the comma there, it becomes a complex sentence. So, like we was talking about speaker models, we talk about independent speaker models and dependent speaker models. Independent addresses large group of people, right? Dependent is specific to a particular speaker. Like you have many of these plugins and extensions and browsers and Word and PowerPoint where you can train that particular model very specific to a speaker. Now, what is diarization? Diarization is, let's say you get a voice or audio, you have to break it down into different segments. How do you break it down to segments? Like we talked about, right? John picked up the ball. Right? Let's say it's a complex sentence. Although John was wealthy, comma, you have a segment there. He was sitting with a group of people discussing and talking like a common man. Right? So the idea is breaking down the speech into different segments and identifying, mapping them based on either template or independent or speaker specific models. Or you can have a neural network model which keeps learning based on independent or the speaker specific model. So let's look into speech engine. Now you understood the speaker model, speech type. You have audio coming in. You have the grammars and acoustic model, and you have the recognized text. Right now, what are the various other factors which the speech engine has to look at? Right now, we are traveling in a car. We have a voice-based assistant, and you're ordering coffee in McDonald's, right? And you're listening to a phone call, right? And you want to check on your mobile, right? You see the interaction. There's environment there. There is one phone call where the speech is coming in, and now you want to get into the another phone and activate or talk to a knowledge assistant or a voice assistant through voice. So how does this voice assistant isolate the environmental noise, the phone call audio, and detect what I'm going to say and act upon? So that's the challenge most of the time the voice assistant have nowadays, right? And other the speaker, we talked about the speaker dependency, and also the style, right? We have Asians, we have Americans, we have Europeans, we have Africans, we have Chinese, in Asians also Chinese and Indians. There's a lot of differentiation in the way we talk. The accent is very different, and also gender, right? Male and female, and you have age, the way the old people talk versus a young guy or a small kid is very different. And the speed, right? Typically Asians talk very fast, whereas Americans and Europeans go very slow. So the speed also matters across different countries, various different countries, and varies with different types of languages also.
Yes, indeed. And just while we're talking about that, of course, back in the early days of speech recognition, you would have invested a lot of time in training the system. You know, if it was on a computer, saying the quick brown fox jumps over the lazy dog or whatever it might be. But when we're on the end of a telephony connection, we have to take a very quick guess, well, not guess, but a quick estimation of what is being said. And that's in addition to dealing with any difficulties there may be on the telephone line, like you said, the acoustic model and any crackles and pops there might be.
Right. So now we looked at the speech engine, we looked at the speaker model, right? We looked at the different speech types. Now you have speech analytics, right? Within the speech, it's not just words, it's not just template based, it's not just a dictionary or a database of words, right? There are emotions, right? The way I want to stress on this and show energy in saying this, right? So the way I say this, I show energy. So there's emotion towards it, right? Sometimes I will talk very slowly and I'm very dull and I'm not even motivated to say a single word, right? So you have emotions and you have locations and you have periods of silence. Sometimes I'm thinking now, I stop for a second, then say, now I thought about it, I'm going to say this. So, how do you go about identifying the periods of silence? How do you go about identifying emotions like anger? I'm very angry and I want to stress this word saying that, can you please do this? Right? So, you have periods of silence, you have emotions, you have non speech, and you have to gather these analytics and then identify within a particular, what you call, an audio segment, then the what you call sentiment analysis, right?
Right.
Whether person or a customer or a patient is very angry or is he energetic or is he enthusiastic or he wants to convey something, or is the silence is the reason the silence the reason behind the silence is he dull, right, or is unable to talk. So how do we need to use the audio using AI, using natural language processing, and also looking at emotions and periods of silence and non-speech to detect emotions, to detect sentiments. So now let's look at voice assistants. Right now you have a voice assistant right here,
Yep.
right? And you have, let's say you're using Google Dialogflow and you have a platform built through Python and Django, and you want to make a query, let's say a very simple query, right, which is show me a customer report. that goes through the internet and then looks up the dialog flow. What are the intents saying, or what are the intents which match to search for customers, and look from the list of intents, pick that intent, send it to the web server. That web server may query some data from the database and send the response back through the internet.
Okay.
Now let's look at a little bit on the architecture front. Right? You have visualization layer, which is HTML5. You have services layer. You have data access layer, and you have database, relation database, MySQL and NoSQL. And you can have standard reports, dynamic reports, customer reports, searches, and query builder. Pretty much all these can be done through voice capability. Right? You can have voice assistant. Now, this is more a process flow where you, let's say, you have a web application or your mobile application, or let's say you're using a simple desktop application, and through this you just say a word, a command, search for customers. This particular command goes through a particular service, which can be a REST web service, and that makes a call to data access. There will be queries, right? And you have database access and goes back as a response.
Right.
Right? That's standard process flow. Now, let's look at the challenges. We have been talking about a lot of good things, and when I see most of the customers get excited seeing the previous slides, and immediately they ask this question saying that you talked about great things, Bhagwan. Can you tell me what are the challenges in creating voice assistants? You talked about how speech can be processed, speech engines, speech types. What are the challenges? Let's look at the challenges. uh, browsers are not compatibility is a problem, right? When you create the voice, each and every browser has a separate DOM model or separate voice capability, right? And let's say you have mobile application, it
Mm.
depends on the mobile OS. Let's say you have desktop OS, there are issues with the desktop OS in whether the drivers are installed properly or whether they are disabled or enabled. And most of the time we have speech hardware issues, which luckily we overcome today, but it happens in most of
Mm.
the time.
Yeah.
And there are
Agreed.
challenges in mobile, desktop, web, all kinds of hardware devices. Now 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 let's say you understood the challenges. You know, let's say pick up something like Google Dialogflow or Amazon Lex system, right? In Watson, how do you go about building a voice assistant? What do you look for? So you first try to understand the voice assistant persona, right? What kind of voice do you like? What It's not just about speech, audio, right? What's the personality you expect from the person, right? And what are the personality traits expected from the voice assistant? What are the psychographic traits? What are the personality attributes? And how will the accent be? Right? That relates to gender, style, accent style, and demography, which country belongs to, right? And when you create the intents, like you talked about searching for customer, right? Or in healthcare, let's say storing the what is my glucose count, right? What's my current weight, right? What is my height, right? All these intents have to be created, right? How do you go about analyzing the intents? You have to worry about the auto recognition. You have to worry about accuracy. You have to worry about message funnels. You have to worry about phrase clustering, right? And what are the different slots and what are the entities associated with the particular intent? And most important thing is the metrics. See, on the voice assistant, you track the metrics where things went well and where things did not go well, right? And you need to track where things did not go well and try to benchmark, have a goal for what you call a threshold. And if the threshold is not reaching, you need to keep on improving the metrics and keep on improving the accuracy. So great example, right? And now a very simple example, and it also depends on accent and where you're coming from. But how many ways can you say lunch at McDonald's for 34 $35 for a client visit. On the right hand side, you see right here you have a list of at least more than 10-15 ways. So $34.35 lunch at McDonald's, $34.35 at McDonald's, $34.35 at McDonald's for a client visit, $34.35 McDonald's lunch, $34.35 spent lunch, and you see here 3rd October 2018, December 12, 2018, lunch $34.35. So there are various ways of saying the same thing, and you need to handle the different utterances, and you need to make the model more accurate. Now, let's say you have the voice assistant. Where does this voice assistant fit in, right, in an AI platform, right? Now we're getting into the healthcare AI platform. So, a typical healthcare AI platform has plugins, extensions, right? You have e-learning platforms, you have visualization capabilities, right? And you have event hosting, right? You have podcasts, video, polls, surveys, right? You have
Yeah.
payment gateways, you have transaction engines, you have wallets, you have CMS content management system, and gamification, personalization, right? And there'll be a lot of internet data sources where you get the data and use the fact checker, right? And curate the content, right? And you have recommendation engines, you have OCR platform, you have loyalty management, and you have data standard data access layer integration and services. And sometimes you use digital pen and you use IoT to detect the events from the digital pen and capture the data which comes through the event.
I would never have thought of all of those different boxes back then.
So let's look at the AI platform and how it interacts with the IoT devices through the cloud. Right? On the right, you have doctors and pharma companies, patient pharmacies, right? And you have associations and allied services and different players in the healthcare ecosystem, and they interact with the different IoT devices, applications, services, right? Through different data formats. It can be HL7, it can be XDR, it can be FHDR, and you have a message store which helps in storing the messages and also transforming the messages through different integration approaches. So let's look at the architecture, right? You have patients, you have doctors, right? And they use web applications, they use mobile applications, right? And the messages or the what you call the requests can go through the cloud, and they go through the API gateway, and you have different IoT devices which are related to heart rate, related to light, related to sound, right, and related to temperature, and you have proximity, you have accelerometer, and orientation. Yeah, let's try to visualize a platform which brings in different players from the ecosystem, right? You have doctors, you have pharma company employers, and you have patients, right? And you have different users, and you can have groups of doctors, group of patients, right, and group of employees from hospital, and group of pharma companies, like scientists, and there's content which is targeted towards doctors, content targeted towards employees and scientists in pharma companies, and you have blogs, and it can be you can have a B2B marketplace which has products targeted, and you have hospitals and clinics providing product reviews, like for example healthcare equipment, right? They can provide product reviews, and you have social interactions, you have audio video chats, you can have set of doctors, right, doing a triage over especially during COVID-19 kind of scenarios. They can do a triage over a patient case and provide support for pathological diagnostic centers, and also, let's say, surgery is required or some kind of healthcare is required, where which hospital is the best place for healthcare, or let's say if surgery is required, right, in terms of how, who will be the right surgeon who can do the surgery, and where this particular pharmacy, where will the medicines be procured, or which pharmacy will be used. And you can have discussions across doctors and across different players in the healthcare ecosystem. You have polls, surveys, and you also have within the groups have group discussions, and you have services, and also you can have events and news and careers for hospital employees, partners, vendors, and customers. So let's look at contact center solutions, right? And you have in a contact center solution, you have customers talking through mobile and web, and having issues and having queries, having questions about deliveries, and you can voice assistant substitute the call center agents. Answer is yes. And also, can we have a next best action which provides the capability to for the voice assistants to work with really tough customers, right? A next best action who is analyzing a frustrated customer can suggest a discount or a coupon, and that makes the frustrated customer who or a patient who is on the call happy, and then move away from the current issue or problem. That would be a great win for next best action win engine and voice assistant, and whether voices can really substitute the call center agent. Now let's look at some of the examples, right? And how where voice assistant really can help. Can it replace a human customer service? We looked at the contact service solution. That's where one area. And can they mirror the live agent conversation? Can we have a white label chatbot customer with immediate way of declaring claims? Can we have a cohesive experience across online and offline channels for claims processing? Can we have freed up live employees to improve the business or grow the business? Answer is yes, that's the voice assistant. And in healthcare, let's start from the reception, right? And you have a patient comes and then he talks to the reception to get an appointment. Can we have a receptionist substituted through AI assistant? Answer is yes, you can have a voice assistant who will help you in providing appointments for the doctors. Can we have instant help for patients? Can we have virtual nurse? Apparently, during this COVID 19 pandemic, there are around 28 million nurses required across the world, right? And there is a deficit of 28 million nurses. Can at least 10%, 20% substituted through virtual nurse? Answer is yes. The virtual nurse can substitute an actual human nurse by what you call standard reminders and tablet reminders or refill reminders, right? Or diet reminders or exercise reminders or fitness related reminders. All of this the virtual nurse can take care of. Right? Can we have a voice assistant help the physicians comply with pre-surgery protocols and procedures? Let's say a surgeon wants to get into a surgery. Can we have a voice assistant providing a basic set of protocols followed, where voice assistant goes through the whole set of protocols and procedures in detail, right? Again and again for different surgeries without getting stressed. Answer is voice assistant can probably do a better job than an actual person going through procedures and protocols. Can we have voice assistant offer self-care instructions or healthcare guidance? Can we have voice activated smart room, especially for elderly people, and also provide patient health info? And these are the areas voice assistants really help in the healthcare. And also, there is a great opportunity on the pharmacy front. Can you have voice assistant helping out on prescription recognition assistant to improve the accuracy of the prescription? Most of the time, handwriting is a big challenge for the doctors and also pharmacists to understand the doctor's handwriting. And you have hospital staff most of the time having problems in understanding doctor's handwriting, right? And can we have a voice assistant help out for refills or for as a chemist agent? Or can we have a voice assistant in the pharmacist network communication? And can we have voice assistant which is multilingual, not just English, French, or Hindi? Can we have voice assistant for ordering medicines online? Answer is yes. And most of the customers keep asking this question, Bhagwan, you have multilingual voice systems, you have knowledge systems, and you have connected systems interacting and through different vertical architecture styles and IoT and through cloud. What is next? So let's say, right, and you're talking to a customer and you're in healthcare domain, and you come up with new requirements, right, and you have pretty much understandable requirements. Can we have a AI coder which looks at the basic requirements? Like for example, we every time you have a diabetes test, right? Right? Based on the test, you capture all the results for the glucose, results for the blood count and cholesterol and all other related metrics associated with the particular diagnostic. Can we store them? Can we create a voice assistant dynamically using AI coder and deploy it on the dialog flow through DevOps and integrate that through to a conversation interface through a voice assistant or a digital assistant through web or a mobile, creating an Android app, creating an iOS app, creating a what you call hybrid web app? Answer is yes. That's the next level which you're going to. Now let's say you have the AI coder and you have the dynamic program creation. What is next? Can we have a no code automation platform? Like pretty much there's no code at all. You visualize, you drag and drop things, you draw the process flow, you write the entities. Pretty much looking at the process flow and the entities, can it generate the voice assistants, the dialogue flow programs, and you have the conversational apps required, mobile apps and web apps, and deploy it using DevOps on the cloud, and you get the mobile apps from the Play Store, right? Is it possible? Answer is yes. You have a no-code automation platform, which is possible to take it to the next level, where we just not have multilingual assistants or learning knowledge assistants or connected systems. We have dynamic program creation associated with no-code automation.
Well, thank you.
Different role.
That was very interesting. And you actually headed off my last question, because usually on a ClueCon Weekly, when I've been talking to a subject matter expert about what is going on in their sector, the last question I ask is what's next? What's coming in the future? But you headed that one off in your presentation, talking about what was coming. And it's very interesting that you should talk about no code environments or for development, because at SignalWire, that's something we're working towards. In fact, the other day we were discussing things
That's
like,
great.
for instance, embedding video collaboration into a given application as easily as one could embed a YouTube video, which is usually a few mouse clicks here and there. So that's something
That's
we're
great
working.
to hear.
Well, that's great. Bhagvan, thank you so much for coming along today on ClueCon Weekly and sharing some of your expertise, and particularly in the medical field is a very important thing right now.
Yeah, thanks, David, and nice talking to you. The latest I read, what's next, is apparently they're using facial recognition to identify a patient's problem and speech characteristics to identify a disease. So, on that note, thanks for giving this opportunity on ClueCon Weekly. It was nice talking to you.
Thank you. You're very welcome, and I hope to see you soon.